Hi class, in our last section we're going to do a quick review of decimals, and that's going to be the last section for our semester. And one of the problems that you're going to actually be or it's going to show up on the homework assignments is the actual place value for the decimals. So technically these are your ones place, and we're talking about the decimals, any value in this position. Okay, let's take a look at the first example. So the first example, what they want us to do is basically to express the fraction as a decimal and provide a sketch. So let me do the sketch of 1/3. And exactly what we did before. You have an integer, you're dividing it into a total of 3 parts. When we had an integer and we divided it into 3 parts, in this case, well, 1/3 represents just one of these actual pieces. Now, to express it as a decimal, and a decimal is just another way to express a fraction, you're going to have to carry that actual division. And you're basically just doing the following, and you only need a total of 2 decimal places. Keep track of the homework assignments though, some of them may want more. So technically, as you carry the division, you're going to have the 3 on the outside and the 1. And then obviously the values of 3 doesn't fit into 1, so we go into the decimal place. As we put the decimal, we introduce a 0, and then we start carrying the following multiplication. So 3 times what gives you a value close to 10. Only if you're looking at 3 times 3 is equal to 9. Don't forget that as you're doing the long division process, there's a subtraction, and then you're gonna be adding afterwards. So 10 minus 9 is equal to 1. At this point, we end up in one of these repeating loops. So as we drop another 0, as we go into the actual into the 100th place, well, we have to add another 0, and then 3 times 3 is equal to 9. And then if we happen to subtract, we're gonna end up with, well, in this case, 0.33 repeating. So our answer for this one, be careful on how the homework wants it. So here you could actually say that this is approximately 0.33 repeating. At a minimum, you need 2 decimal places. You don't need to go beyond that, but that would be perfectly fine. And we always write it as approximately. That's because, well, keep in mind that we're losing precision as we're actually carrying out this, well, division, since technically 1/3 as you go to a decimal, it's never going to be an exact value. That's because of this ending decimal. Okay, let's take a look at problem B. And in B, it's a regular 1/5. So the actual sketch that they're talking about, or on the homework assignment, some of these may be multiple choice. So you just have an integer, and this particular integer is going to be divided among a total of 5 pieces. So not to scale, but 1, 2, 3, 4, and 5. So 1, 2, 3, 4, 5. And then the value of 1/5 basically is just going to be that shaded region. So as we carry this division, we're going to end up with, well, technically 5 on the outside, and 5 doesn't fit into 1, so we have to put a decimal, add a 0, and in this case 5 times 2 is equal to 10. As we go to the next step, we have to subtract, and then our remainder happens to be 0. In this case, we're just rewriting that 1/5 is equal to 0.20. So that's going to be our final answer for this one. Okay, let's go to the next one. And in this case, before we carry the division, let me express it as an actual, well, in this case, as a mixed number. So this is going to be 1 and 1, 1/4. And as we technically provide a sketch for this one, so this is going to be our integer, and then this is the other portion. So just to be clear, let me rewrite it as this is technically 1, and then on the other portion you're going to have 1, 2, 3, and 4. So we're talking about that being our integer, and then technically this portion is the 1/4. So as we express this one as a decimal, you're just going to carry out this division of the 1/4. So we're talking about, well, technically 4 on the outside, 1 on the inside. And as we go into the decimals, we put a decimal point at the 0. In this case, 4 times 2 is equal to the values of 8. After we technically subtract, we're going to get the values of 2 and drop another 0. And then this was going to close here because 5 times 4 is equal to 20. Your remainder, it's actually going to be 0. So in this case, this is 1.25 as our final answer. Okay, let's go to example 2. And in example 2, what they're giving us is, well, in this case, a couple of integers and also a couple of single actual rows of the integers. So notice that this one, and let me count it just to double check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is technically a 10 by 10 grid. And let me just count this one. It's supposed to also be a 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a 10 by 10, making this one also a 10 by technically 10. And then, well, each of these represents 1/10 because technically it's one of the rows of tens. And then each of these actually represents 1 out of 100, since the total grid of, well, each of these two, and I'm talking about, in this case, this particular one, it's going to have 100 pieces. So 100 pieces. So the actual decimal number for this particular one, it's going to be equal to the following. So this is equal to the following. So technically 1 plus 1, which is going to be 2, plus we have 1, 2, 3, 4 rows of 1/10, plus I have 1, 2, 3. So I have 1, 2, 3, 4, 5 times 100s. And then at this point, you can change them all to decimals. I'm just going to rewrite the first two as 2, since technically this gives us the sum of 2. And then plus 4 over 10, it's actually technically 4, plus 5 over 100, it's 0.05. So your final answer is going to be 2.45. This is how they're expressing this particular one based on the shapes. And once again, the shapes are 10 by 10. It's a 10 by 10 grid.